so far we've talked about systems of linear equations with two variables. Now what we're going to talk about is linear equations with three variables. Now we have like an x, y, and z if you're looking at this first example. And because of the fact that we have three variables, we have to have three equations. So whenever we had two variables, we used a system with two equations to be able to solve for x and y. But now we have three variables. And basically with the process that we're going to use is we're going to use elimination. So when we get our solution set for this three linear variable equations, we are going to have three variables as the answers. We're going to have an x, y, and z, which really means our space that we're talking about is three-dimensional because x and y are just on a flat coordinate plane, but once you add in that third variable, it's really adding in a third dimension. So z is like almost coming up off of your paper. So we're not going to worry so much about the graph of it, but we're going to look at how do we solve the system for x, y, and z. So when we look at this system, the first thing I'm going to do is I'm going to label my different equations. I'm going to label them with letters just so it doesn't get confusing. So this is going to be A, this one will be B, and this one here will be C. And what I want to do first is I need to eliminate the same variable in these three equations so that I can first get these down into two variables. So what I'm going to do is I'm going to group A and B together first. So I'm going to take A and B, and I'm going to group them. So I have x plus y plus z equals 6. And then B is 2x minus y plus z equals 3. And what I need to do is I need to eliminate some variable in this equation, in this set of equations, and it's going to have to be the same variable that I choose to eliminate with B and C. So basically you're going to take each individual piece here and you're going to eliminate the same variable in A and B as you do in B and C. So let me just write B and C down. So B, so I'm just copying these down first. So let's look at some variables that would be easy to eliminate. So if I look at this first one, I'm seeing right away that these y's are just going to automatically cancel. So if I choose to eliminate those, that would be a good place to start, because if you look at the second set of equations, it wouldn't be hard for me to eliminate the y's in B and C. So let me go ahead and eliminate them over here with A and B. So I have 3x, those are gone, plus 2z equals 9. So now I have a new equation. This new equation, let's call it D. And then over here, I'm going to eliminate those same y variables, but the only difference is I'm going to have to change one of these equations in order for those to cancel. So I'm going to have to change this equation here. So this top equation. So if I multiply everything in the top equation by 2, that will allow my negative y to become negative 2 and add it to positive 2y, and I'll cancel. So let me go ahead and eliminate or change this first equation so that I can eliminate. So I have 4x minus 2y plus 2z equals 6. Down below I have x plus 2y minus 3z equals negative 4. I'm not changing that second equation. So then go ahead and add these. So we have 5x, those are going to cancel, minus z equals 2. This is my new equation that I'm going to call E. So now I have a system of a two-variable equation. I have D and E that are two equations with two variables, which means I can solve those for x and y using lesson 3, which is what we just did. So in the previous lesson, we had two equations that had two variables, and we used elimination to solve them. So I'm going to go ahead and take these two equations and I'm going to solve them for either x or z, and then take x or z and plug it in to figure out the other variable. So now you have to ask yourself, going back to what we learned in the previous lesson, how do I eliminate one of these variables so that I can get the other by itself? So I'm looking at the z's. Those look like they're going to be the easier ones to cancel because I have a -1 below and a +2 up top. I can make this second equation have a -2z in it by just multiplying everything by 2. So I'm going to go ahead and I'm going to multiply everything by 2. So up top, I'm going to leave my equation as 3x plus 2z equals 9. And then below here, I have 10x minus 2z equals 4. And again, I chose to multiply by 2 because I needed this z to become -2 so that it'll cancel out with the z up top. So the z's are going to cancel, and I have 13x equals 13. Divide everything by 13, and we get x equals 1. So there's one of my answers. I need to get an x, y, and z. So now that I know x equals 1, I can take this and I can plug it into either of my two variable equations. You don't want to plug it into the original a, b, or c because it's still going to leave you with an equation with y and z. So what you want to do first is you want to figure out z so that you know x and z, and then you can plug those in to figure out y. So this one you have to plug into d or e. So equation d or e. So pick whatever one. Let's say I use d. So if I plug that into d, let me just copy down d first. So equation d is 3x plus 2z equals 9. So you're going to take that, you're going to plug it in. So I have 3 times 1 plus 2z equals 9. So I have 3 plus 2z equals 9. Subtract 3 from both sides. So we have 2z equals 6. Divide everything by 2. And you have z equals 3. Now that I have z equals 3 and x equals 1, I'm almost done because I can now figure out what y is since I know x and z. So I can figure out y by going back up here and plugging into one of these three equations. It's going to be probably easiest to plug into that first equation. So let me plug into equation A. So I'm going to take these and I'm going to plug them into equation A, which is x plus y plus z equals 6. And that will allow me to solve for that third variable. So I'm going to plug in 1. I'm going to plug in 3 for z. So I get y plus 4 equals 6. Subtract 4. We get y equals 2. So now my solution, we had x equals 1, y equals 2, and z equals 3. And when you write your solution, you write them as an ordered pair, but it's with 3 variables. So it's actually going to be 1, comma 2, comma 3. You always write it as an x, comma y, comma z. So it's an x, comma y, comma z, since that wasn't very readable. That's how you're always going to write your solutions. So this is your answer, x, comma y, comma z. And again, you can check your solutions by taking x, y, and z and plugging them into each of the original 3 equations. That's how you would check your solution for this. So let me show you one other example. I know these are long, but I want to show you at least one other one where we have variables missing from the original. So here I have x, y, yz and xz. I know that this still has to be a 3-variable system because there's 3 variables total. So basically what this looks like, if I were to rewrite this, this first equation would be an x plus 3y plus 0z, because 0 times z would be 0, that's why you don't see it in the original, equals 5. Then I would have 0x plus 6y plus z equals 12. And then down below I have x plus 0y minus 2z equaling negative 10. So if you want to follow the same process that we did in the previous example, you would start off by labeling these A, B, and C. And then remember, you group A and B together and try to eliminate one of the variables. So x plus 3y plus 0z equals 5, and 0x plus 6y plus z equals 12. And then you can group B and C together. So we have 0x plus 6y plus z equals 12, and x plus 0y minus 2z equals negative 10. And basically what I want to look at is, since I have all of these zeros in there, I want to look at a convenient way to kind of shorten the process. So when I compare these two sets here of equations, I say, like, look at this first one. I can't really eliminate in this first set. I can't eliminate the x's or the z's because I have zeros in one of the equations. So you can't multiply something by 0 and get a number other than 0. So basically what that means is I'm not going to be able to use elimination to eliminate x or z. So that kind of leaves me with trying to eliminate the y's. But then when I go over to this set over here, that would mean I have to eliminate the y's over here, which really means you can't. You can't eliminate the y's because the bottom equation has a 0. So basically this is going to be one of those unusual cases where you're going to eliminate y in the first equation, but when you get down to the second set, B and C, you're not going to use B because you don't need it, because if you look at C, C already has y eliminated. So I can skip the whole elimination process for the second set and just use C as my 2-variable equation. So let me go ahead and go back to this first set where I'm going to eliminate my y. So I'm going to have to change these. If I have 6y in the bottom, 3y can become negative 6y by multiplying everything by negative 2. So go ahead and multiply everything by negative 2. So I have negative 2x minus 6y. This is just going to be a 0 for the z, so plus 0 z equals negative 10. And then down below I have 0x plus 6y, just keeping everything as is, plus z equals 12. And then go ahead and add these up. So I have negative 2x my y's are going to cancel, plus z equals 2. So this is my new 2-variable equation, so I'll call this one D. And normally we would have to figure out equation E by using B and C to get that. remember, I already talked about how we can't really use equation B to cancel out the y in the two equations, because if you look at equation C, really that's just a two variable equation, so I don't need to do a system to cancel out my y's. I already have a y canceled in equation C. So now I'm going to use D and C, since they both are two variable equations with the same two variables. I'm going to use those equations. So equation D and equation C, I'm using these two equations, and now I can cancel. So I need to eliminate one of the variables. So let me eliminate x this time. It doesn't really matter, but if I want to eliminate x, that means this bottom equation's got to get multiplied by 2, so that when I have negative 2 plus 2, they're going to cancel. So I'm going to multiply the bottom equation by 2, which just means I'm keeping the top equation as is. So the bottom equation, which is C this time because we didn't need to create an equation E, is 2x minus 4z equals negative 20. Go ahead and add these to eliminate. So the x's are gone. I have negative 3z equals negative 18. Divide everything by negative 3. We get z equals 6. So now that I know what z is, now it's the same process as the last example. Figure out what the other variable is by plugging into D or C, plugging into one of the two variable equations. So let me go ahead and plug into D. Doesn't matter which one, I'm just choosing one of those two variable equations. So D is negative 2x plus z equals 2. So I'm going to plug in z so I can figure out x. So subtract 6 from both sides. So we have negative 2x equals negative 4. Divide everything by negative 2. So we have x equals positive 2. And then our last stage is to find y. So we're going to take one of our original equations, whatever one's easier. Just make sure that you don't use c, because if you use c, notice that equation c from up top doesn't have a y variable in it. So we really need to use a or b. So let's just say plug into a. So a is x plus 3y equaling 5. You would plug in your x and your z. In this case, though, I don't have a z, so I'm going to go ahead and I'm going to plug in just the 2, and I'm going to find what y is. So, subtract 2 from both sides. We have 3y equals 3. Divide everything by 3. We get y equals 1. So we have x equaling 2, y equaling 1, and z equaling 6. So now your solution you write as an x comma y comma z, so it's going to be a 2, 1, comma 6. So that's your solution. So it's the same process, it's just you got to skip one of the steps, one of the elimination steps, because you were missing some variables to start. So that's it. Make sure you rewatch, the first and second example if you need to, just to make sure that you're getting the process. It's the same process every time, but it is a very long process.